In this video, we're going to look at doing chi-square tests of association in Stata. So essentially, we're going to look at two-way tables. We're going to look at chi-square tests of independence or association. So if you want to follow along, you can download this data set. The link is available in the show notes. If not, let's go ahead and get going. What we're going to basically do is we're going to use the two variables I have here that are categorical, gender and race, and we're going to conduct a chi-square test. Essentially, we just are going to use the tab or tabulate command and put in our two variables in either order. And if I just hit enter now, it's just going to give me a two-way table with all the information in it. Okay, if I want it to conduct a chi-square test, then I just type in comma chi2, chi2, and that's it to conduct the basic test. Okay, for the very basics, I have my p-value right here, chi-square with 2 degrees of freedom, and this is the test statistic value with this here. So you see, not statistically significant. Now, of course, there may be some other things I want to look at, so I'm going to go through some of the options here to let you look at some of the other things. One of the things you may want to look at is expected values in each cell. You can just type in expected there as one of the options, hit enter. And you see we've got expected values listed for each cell. Now, the assumption that we need to look at here for chi-square tests is we need to have at least 80% of these values, these expected values, 5 or greater. They all are in this case, and 100% of them, all of them 1 or greater. So you see in this case, I don't have any problem with that. If I did, what you can do is collapse cells, combine the 2s and 3s together if, say, those were too small. Something like that, so that we have all the cells with expected counts greater than 1 or greater, and 80% of them at 5 or greater. Now, you can do that using doing some recoding. If you look at one of my other videos I have available on this channel, you'll see that I have a video that shows you how to create new variables or recode, and that might be helpful to you if you have that situation come up in your own data. Now, some other things that you might want to look at, I'm going to take this expected out so it doesn't get too cluttery, is you may want to look at frequencies or percentages, essentially. We by row. So here we're looking at percentages by row, okay, in each cell. Or I may want to look at that by column. So I just put in col instead of row, and you're going to see the percentages by column instead. Okay. The other thing you might want to look at is you might want to look at the chi-square component by cell. This is helpful if you do get statistical significance. The value of the test statistic here is right here, but this will tell you how much of it came from each of the cells here. And that will give you an idea wherever the largest values are, there's the biggest difference essentially between the observed count here and the expected count. So if I go ahead and put that in with the expected at the same time, and you see I can just use the abbreviation. I just typed in EXP. Usually you can use the first 3 or 4 letters of a command or option, and it'll recognize what it is. So here you'll see that all the differences between the actual observed count in that cell and the expected counts are fairly small. Okay, but the ones that are a little bit bigger maybe have this, like this one has that 0.2 associated with it. It's a little bit bigger. Okay, so that's the chi-square component associated with that cell. So if I did have statistical significance, it would show me right off which cells were the biggest contributors to that, and it also show you for the whole columns and the whole rows where you're seeing the most. So that's really all you need to look at here, and I hope that was helpful to you.